Hello, I recently did a video about what I've learned 3 years as an embedded software engineer. So one of the comments was left on that video was asking, where do you start if you want to get involved in that sort of field? So I don't really know the right answer to that, but what I do know is how I got involved and interested in it and things like that. And what I did, I kind of went an unconventional route. Maybe it's conventional, maybe it's unconventional. I'm not 100% sure because I don't know for certain, but I can basically talk about the route that I took to get where I am in terms of what I know and being an embedded software engineer. Although sometimes I don't feel like it. The first thing is learn the basics, and I don't mean learn the basics of programming, I mean learn the basics of circuits. So resistors, capacitors, LEDs, power, ground, learn the basics of that, learn the maths, physics, and you can test it. And the best thing to do is test it with an online simulator like I have here. So this is called every circuit, and it's basically just a wee simulator that you can use to test electronic circuits with. So if I get, that's a power source that you can just think of this as a battery. That's a resistor, and if I just get a wee LED, and if I plug that all together and hit go, it will give me a rough idea of the current flowing through it. And yeah, you can just watch it manually, and it's kind of, it's relatively safe, and you don't need to worry about having to buy components or blowing anything up or putting anything on fire or anything like that. There you go, there's about roughly 79 ohms there, 3.3 volt battery, and it's lighting up the LED, and you can see that there's about 17.8 milliamps flowing through in that circuit. So yeah, you can learn basics for things like this and test it, and you can do loads of other things as well. So there's loads of examples, there's recent ones, popular ones. There is a book here, so there's a capacitor oscillating. So this is the oscilloscope up the top here, and that shows you the capacitor charging. And then if you hit that, it's discharged, and that'll charge it again if you open the switch. The current source here, it's charging and then discharging. There's things like that you can do. And the best way to learn and do all this stuff, if you don't have a course or if you're not doing a course on electronics, the next best step is to do it here and build mini projects and things like that. There is also a game as well called Virtual Circuit Board, and it can teach you the basics of logic gates and things like that, and assembly programming. Although I would not recommend assembly programming as your first protocol in terms of learning to program. So that's the first thing on the list, is learn the basics. So once you've got that done and you're pretty confident with the hardware and things like that, the next thing you can do is learn to code. You can do this by getting your first Hello World program up and running. So this is an online C compiler, and these are good because it takes away all the effort of having to set up an IDE or a text editor or things like that, and it lets you just get down to actually practicing coding. And yeah, the basic thing for programming is Hello World. Hello World sounds and looks really stupid, but it's really not. And it's really not because it's the quickest and most effective way of making sure your compiler, if you're doing this manually with a compiler and IDE that you've set up, it's the quickest and easiest way to check that your compiler and IDE is working fine before you continue to go and make more complex applications and things like that. So that's the first thing to do, is get your Hello World program up and running. And the best way to do that is with an online compiler. So that's step 2. Okay, you've got your hardware down and you've got your basically your programming down, both of them separately. You've understood both of them separately and you're pretty confident. Now the best thing to do to be an embedded software engineer is to fucking mush them together and make them have really ugly, that's not true, have a really beautiful child, because hardware and software work together in harmony. So yeah, how do you do that? You get an Arduino kit. This is mine, so I have another Arduino on a breadboard here and a sensor, but don't worry about them. So this is my Arduino Uno. This was the very first microcontroller I got in this SparkFun electronics kit with this red breadboard, which is stuck onto this plastic. But basically, if you want to get yourself one of them kits, now you can get these kits pretty cheap on Amazon, so you can. And even if you don't want a kit, if you don't want an Arduino one specifically, but the Arduino kits come with nice wee, I don't know if it's a box or a book. I got a wee book with mine. It was a nice big kit full of proper real good components and things like that. Or you could do what most other people do, and there's nothing wrong with this either. is get one of these kits. So they're basically the exact same microchip, so it's kind of hard to see there, but that wee microchip on that there is basically the same as the microchip on this here, and most of the code will run the same on it. And you get all this extra stuff as well, so you get LEDs, light sensors, capacitors, a shield, breakout board, a wee battery, loads of resistors, a remote, potentiometer, loads of crap. So get yourself one of them as well, and then just do the exercises in it that come with it. And then the next thing to do whenever that arrives is get the Hello World version of it working, and that's basically an LED blinking on and off every second. Yeah, and then whenever you do all the projects and things like that from those boards and kits, then the next thing to do is come up with your own projects that are pretty funky. So one of the projects that I actually made was, I don't know if I have it or not, I need to look. Okay, so I made an electronic version of Newton's Cradle, but if I have one, I'll try and put it up on the in the video. Yeah, once you've got those three done, you're kind of on your way in terms of, you know, you've got your feet under the table. So the next step is to actually try and set up some legit developer tools. So one of the more well-known microcontroller boards that I've used in my current role is a Nucleo board from ST. These are pretty common for a lot of businesses and things like that, and they are relatively straightforward to get working with. Most of them come with the Arduino pinouts on them, and yeah, they're basically compatible with them as well. So if you get one of them boards, you can program them using the Arduino IDE, and then once you have that and you're comfortable with that, then you can look at using, you can use STM32's IDE, so it's called Cube IDE, and it's basically an integrated development environment which you can use to develop your code in. And the thing is with the ST stuff, it comes with like a code generator, and what you can do is get the code download, or it'll generate all the code that you need in terms of being able to hook up and use peripherals, and it makes it setting up the microcontroller 10 times easier. Whereas if you had to do it manually for this Atmega chip without the Arduino IDE, and you just wanted to use the Atmega code, it's a lot more tedious in terms of you have to write register bits manually. So the CubeMX gets rid of all that. And then once you get Cube IDE and CubeMX hooked up and working, then what you can do is try and get a sensor working. So I have a sensor here. This is it's an accelerometer. I can't remember the model number. GY521. I'll put an image up on screen of it. But you can hook that up. It uses a communication protocol called I2C. You can try and communicate with it and get that working. It's a good place to go as well. Then once you have all that done and you're pretty confident with all that sort of gas, you can learn about source control. So this may or may not go out before I do a source control video or a video about Git or GitLab or anything like that. But if you want to save yourself a headache and any sort of problems in terms of developing code and things like that, source control is the bee's knees. A quick crash course. Source control is a way of tracking changes on your files and keeping a log of them without losing them over time, and it basically takes snapshots in time of that file that you're working on. So that's basically what that is in a nutshell. It saves you having to write 10 files and call them hello, hello 1, hello 2, hello 3 as the code develops, and that'll save you having to look back and go, what the fuck was hello 2 again? So there's that. Yeah, learn the basics of it and get comfortable with it, because it's a must regardless of what you do in software, and it seems to be in hardware as well. Hardware or software, source control, learn it, get used to it, get comfortable with it. Okay, so then what's one other thing? This may be useful, it may not, but one thing you maybe have to do is get comfortable with the terminal. So this is my terminal, but you need to get used to terminal commands and things like that. So if you get used to terminal commands, you'll be able to navigate your folders easier. This may only be relevant if you or your company or whatever start to use Linux and Linux terminals, although you should get familiar with the terminal, because even you may still use a Linux terminal on Windows. That's a conversation for a different video. Yeah, get used to the basic commands, aliases, and just scripting in general, because Linux terminals have their own sort of language called Bash. So last but not least, ask questions. So I've hit this before in a video of this topic, but you cannot be afraid to look stupid, because if you stop asking questions, you'll not learn as much and you'll fall behind. And when you do that, then you're not of any use to anybody or your company, and what's to stop them getting rid of you? I know that sounds kind of morbid and kind of rough, but just in general, life will move on and you won't. So don't be afraid to look stupid or ask questions, and try and find the joy and curiosity, or the joy in being stupid in things, because once you do that, then it'll become less of a problem for you. So yeah, ask loads of questions and make sure you take in as much information as you can. So those were 7 tips about where to start if you want to become an embedded software engineer. I don't know if any of them will be any use to anybody. Hopefully they will. If they are, let me know with a comment below. If they're not, let me know with a comment below. If you're feeling festive and happy and get something useful out of this video, consider subscribing. I hate asking that. That's it for me. I'm gonna go die now from my cold because I'm fucked. So, bye!